all, I'm Professor Janardhana Rao. Today my lecture is operating systems system calls. So first of all, what is system call? Basically, system call is normally a function, so which is written and either in C language or Java language. Then once after compile of this function, we add to the OS. So once you add to the OS package, so automatically it will be a part of the OS only. So that is called nothing but a system call is a normal function, but this function will be used by the system itself. We do without our user interference, system will use it. The system is a way for a user program to interface with the operating system. The program requests several services and the OS responds by invoking a series of the system calls to satisfy the request. The system call can be written in assembly language or a high-level language like C or Pascal. System calls are predefined functions that our operating system may directly invoke if a high-level language is used. I'll give an example. So once you write any high-level language program, C language or Java language, this is a program we're writing. So the user will ask to save it. He will press the save as some. He will write save as some xyz.c, and he will press save. So once that much, you will do that much job. He will write the program, and he will ask the system save it. So the system in turn, what it does, once the user enter press save button, automatically user job is over. So now system will take over from here onwards. So what it does, it will invoke automatically some programs in the OS, that is system calls itself. That system call, this is like write system call is there. Write system call. Right? It is a system call or a function which is available in the OS. This write system call will be invoked by the OS itself, and whatever program you want to save, that program will be written in the hard disk. That's the job. So what it does, you will write some program and you will ask to save. The OS will save further. What the OS will do, it will write this program in the hard disk by using the write system call. So the system will call this write. User will not invoke the write system call. So that's what system will invoke certain functions or programs in the OS. So that will not be invoked by the user. User only write the program and he will ask the system to save it. So further job will be done by your OS. How they are invoking some programs or some functions which are already available or predefined programs available in the OS. These programs will get the job done. That's what system call meaning. So a system call is a method for a computer program to request a service from the kernel of the operating system on which it is running. That's what kernel. The system calls will be available in the kernel. Kernel is also part of OS. So the system calls directly interface with the hardware. That's hard disk. It will write. Suppose we are asked to save it. So save is only the save is the key, and the save will go and invoke the write. So it will write the program in the hard disk. The system call is a method of interfacing with the operating system by a program. It's a request from computer software to operating system's kernel. That's what. So we are pressing save, button save. So automatically it will invoke the write system call, a write program to write this whatever program user written, that will be written in the hard disk. That's what. The application program interface connects the operating system's function to user programs. So save is a save. So only is pressing the save. The rest of the things will be done by the OS. So it acts like a link, as a link between the operating system and a process. Process allowing user level programs to request operating system services. Suppose, similarly, once you open any file, you want to open this, see the any file in the hard disk. So the icon is which is available in the screen. You simply press it. So once you are pressing that button, automatically the user only pressing button. That's all. But rest of the things will be done by OS itself. So how it will invoke from some read system call from the OS that is in the kernel, and that read system call will read the file from the hard disk line by line, and it brings to RAM, and then which is available in the RAM, that is visible to the user. That's what system call does. There's a link. The kernel system can only be processed using system calls. System calls are required for any program that use resources. So that is what system call really does. So how are system calls made? So first of all, we should understand how this OS is made, how this OS is designed. For designing OS, we have to write different programs and compile it and add to the package. Similarly, there is a procedure how to add the programs to the package, this OS package. So that's what there is a systematic procedure is there how to add this predefined programs what you return, and to add the kernel. That once you add the kernel, that will become a system call. So there are number of in OS there are number of programs are there. All are .exe files, but out of this one, some programs are kernel programs. So what is kernel? Already we have discussed in the previous class. The kernel can interface with the hardware directly. So inside this kernel, there are some system calls. The system calls can directly interface the hardware. That's what the difference between the kernel and OS programs. There are a number of programs in the OS, number of programs. So out of these, some programs can directly interface with the hardware. That's it. So when a computer software needs to access the operating system's kernel, it makes a system call. Very simple. That's what I'm explaining. When a computer system needs software needs to access operating system's kernel, it makes a system call. It makes a system call. It will make use of system call. The system call uses an API to expose the operating system service to the user programs. So once you are saving or retrieving data from the hard disk, so simply you cannot get it. So the OS will get it done, and in turn OS will invoke the system calls which are available in the kernel. It is the only method to access the kernel system. So you cannot directly access the write. You can write this as a read and write functions in C and Java, whereas once it is compiled and added to the OS, that is no more function of the user, because that function that is under the handover of the control of the kernel. Like OS, that's the kernel is a part of OS. So all programs are processes that require resources for execution must use system calls, as they serve as interface between the operating systems and user programs. That's what we are discussing. So the system call is a function, a three different functions which is available in the kernel, and they serve as an interface between the operating system and user programs. So below are some of the examples how a system call varies from user to function. A system call function may create and use kernel process to execute a synchronous processing. So what we are doing synchronous OS itself cannot do anything, but inside the OS the kernel is there. The kernel inside the kernel there are some programs, three different functions and programs are there. These programs only execute whatever the user wants. A system call has greater authority than a standard subroutine. A system call with kernel mode privilege executes in the kernel protection domain. System calls are not permitted to use shared libraries or any symbols that are not present in the kernel protection domain. So system calls are restricted to only to work in the kernel. The code and data for any system call stored in the global kernel memory. That's what we are discussing. Once you add, there is a procedure how to add functions or programs to the OS. So, and out of these, some programs will add to the kernel. So these what are the programs we are adding in kernel? They will become the system calls. System will call. So why do you need system calls in operating system? Yes, why do we need? Because for executing everything, we need some predefined programs. So these programs can only interface with the hardware. So there are various situations where you must require system calls in the operating system. Yes. So the following of the situations here are as follows. It is must required when a file system wants to create a delete a file. That's what I explained now. So suppose you write any C program, Java program, you as a user, this is program. So after writing program, we compile it. We compile this program. After compiling, we will save this program. Simply we save as press it. Then automatically the OS will come into action. In the inside the OS, there are some. These are the OS functions and OS, and out of this, some kernel system calls are there. So OS will interface with the system calls, and system call will write this program in the hard disk. That's it. What is the sequence going on? So even for deleting of these files also, suppose you want to delete any file in the hard disk or in your primary system. So simply you cannot delete. So simply you press delete. You select that file and you delete it. You press the delete function, delete button. So automatically OS will come into action, and OS will invoke the kernel. Inside the kernel there is a delete program. That program will execute and delete the program from the hard disk. That's what sequence. Network connections require the system calls to sending and receiving data packets. If you want to read or write a file, you need system calls. That's read system call, write system call. If you want to access hardware devices, including a printer, scanner, immediate system call. So system calls are used to create and manage new processes also. So that's what for every operation, OS is there. Inside the OS, the kernel is there. Inside the kernel, there are system calls. They will get the job done what the user wants through OS. OS will just, you can say, OS is interfacing between the system, our kernel and the user. So that's what. So how system calls work. An application run in an area of memory known as user space. A system call connects to the operating system's kernel, which executes in kernel space. So what we are explaining since the beginning, this read and write, delete, all this execution of the program, all these things will be done by the system calls which are available in the kernel. They will run in the kernel space. When an application creates a system call, it must first obtain permission from the kernel. The kernel is a part of the OS. Okay, for this one. It achieves this using an interrupt request which causes the current process and transfer control to the kernel. So kernel is most responsible. Kernel is a part of OS only. There are some programs in the kernel. These programs are different system calls. So our system call work. If the request is permitted, the kernel performs the requested action like creating a deleting file. Input the application receives the kernel's output. The application assumes the procedure of the first input is received. When the operation is finished, the kernel returns the result to the application and moves the data from kernel space to user space in the memory. So once the job is completed, automatically the control will be handed over from the kernel mode to user mode. That's it. So a simple system call may take few nanoseconds to provide the result, like retrieving the system date and time. A more complicated system call, such as connecting network space, may take a few seconds. Most operating systems launch a distinct kernel thread for each system call to avoid bottlenecks. The modern operating systems are multi-threaded, which means they can handle various system calls at the same time. So, as in the multi-threading operations, there are different operations will be taken simultaneously. So that is which means they can handle various system calls at the same time. Modern operating system, that is multi-threading or multi multi-programming, multitask, multi-processor systems. So the system cannot function without the operating system, and an operating system cannot exist without the kernel. Therefore, every operating system has a kernel. That's what we're discussing. This is OS. This is OS, and inside this there are number of function programs are there. Every program will work for one application. So there's this some programs will work for memory management, some programs will work for process management, some programs work for the protection, some programs will work for the this one you can say resource management, and different. So apart from this one, we got some kernel, this kernel, and this kernel is the main one which interfaces with the hardware. So the system cannot function without the operating system. That's true. Without operating system, no system can exist. Even our cell phones and our laptops, anything without operating system cannot work. And an operating system cannot exist without the kernel, because kernel is the master which can interface with the hard disk. So therefore, every operating system has a kernel. This is true, because this is designed like this. This is the operating system has been designed like this, in this fashion. So OS inside the OS there are some programs which these programs will directly interface with the hardware. So our access to kernel is restricted. Only OS can access. OS means inside the OS are RR programs only. Out of this one, kernel is also a part of the OS, but these programs, the OS programs, will interact with the kernel. That's what I insisted. So there are different types of system calls as we discussed now: process control, file management, device management, information maintenance, communications, protection. What the basic purpose is in case of process management? Simply we will write a program, a Java program, C program. Simply we'll go after writing the program, compile it. After compilation, we will go for run or execution. So only we press the button to execute or run. So rest of the things will be done by the OS only. But inside the OS, there are programs, the system called programs. They will execute. So that is in OS is the interface in between the user and kernel. Rather, we can say simply. So kernel is the outmost program which interface or which having the control on the system calls. Kernel, the system calls are having the highest priority. I mean, that is means they will only execute the actual thing in the system. So these are the types of system calls: process control for process controlling, file management, device management, information maintenance, communications, protection. So if you look at this one, types of system calls, is you can see as we discuss: device management system calls, file management, process control, communication, information maintenance. So like this, if you just look at this system calls, like this, there are so many system calls working for this system for smooth functioning, full smooth operation. So if you look at this one, types of system calls, uh, process control. What are the system calls coming under this process control? The system calls perform the task of process creation, process termination, etc. What are the functions? End and abort, load and execute, create process and terminate process, wait and signal event, allocate and free memory. So user only press the button, but rest of things will be done by OS. Inside the OS kernel. The kernel, the system calls are there. Suppose you want to end the program, you want to end the about the program. So once you press abort, that's simply you are pressing abort, but OS will understand this and it will invoke the appropriate system call in the kernel. In turn, that system call will function, that will create abort from the execution. That's suppose simple load and execute. Suppose you want to load one program and execute it. So simply the user you will load the program, press the button, is execute. But rest of things will be done by combination of OS and kernel, OS and system calls. Basically, system calls in the kernel. So that's what the kernel will directly interface with the hardware. So in turn, the OS will understand what user intention. So all this create process and terminate process. Suppose we got some system calls in the when we in advance we just need to read it. There is a system call fork. The fork is a system call which is available in the kernel. So suppose we create a child process by we don't directly interface the fork. Only system, only OS, only will work fork. In multi-threading concepts and all, we'll come to know this one. Wait and signal event, allocate and free memory. That is nothing but we are deleting some program. That is deleting means in the sense just vacating the memory or making memory free. That is free memory. That's what everything is done by the system calls only. The system calls are having the direct interface with the hardware. That's what my intention. So in process management, there is system calls are involved. These are the system calls involved in the process management or process control. So if you look at the file management, file management system calls are handle file manipulation jobs like creating a file, reading a file, writing a file. Some file management examples including creating files, deleting files, open, close, read, write. So I'll give you one example. Suppose you have saved some file, some document in the hard disk long back. Okay. So this is a hard disk. You have saved it. So once once you save it in the hard disk, and you will get a indication in the screen also. This is hard disk, and you will get in the screen icon also. You get some icon, some X file is saved in the here. So you want to open this file. You want to open this file, and certainly we will press with mouse on this one on this icon. So automatically OS will understand the user wants to open this file. So automatically the OS will invoke read system call. Open the first of all file. It will find out the file. Then it goes there and by read system call, it is available in the kernel. That system call will read the line by line and bring it to the on your screen. That's what happening. So file management, file opening, delete files, open, close, read. Once you close the file, automatically the close system call will get invoked and it will close the file in the hard disk. So these are the system calls involved in the file management. So the file management, and if you look at this device management, a process may need several resources to execute: main memory, disk drives, access to files, and so on. If the resources are available, they can be granted and control can be returned to the user process. So otherwise, the process will have to wait until sufficient resources are available. A system with multiple users may require use to first request. A device to ensure exclusive use of it. After we are finishing that device, we release it. Then these functions are similar to open and close system calls, what you see in the earlier. So you see, suppose you are executing one program, so it requires some input output. So that time the OS will release that resource from that kernel that system calls will release that input output from other who is holding, and it will be given to this one for executing. So device management is device management. This is called device management. So device management does the job of device manipulation, like reading from device buffers, writing into device buffers, etc. Some examples of device management include read device, write, get device attributes, release, etc. So information maintenance. There are some system calls involved in this information maintenance. Many system calls exist simply for the purpose of transferring information between the user program and the operating system. For example, most systems have a system call to return the current time and a date. Other system calls may return information about the system, such as the number of current users, the version number of the operating system, the amount of free memory or disk, and so on. So, what is actually everything is maintained by the OS only. So, what is the OS? How many times you open the file? What is going on in the system? What is the process number going on now? All these things will be maintained in the OS only. So they will maintain some information. Maintenance of information will be done with the system calls concerned for this purpose. So many operating systems provide a time profile for a program to indicate the amount of time that program executes a particular location or a set of locations. A time profile requires either a tracing facility or regular timer interrupts. At every occurrence of the time interrupt, the value of the program counter is recorded. So how many times this file is opened in that day, for the last week, for all these things you maintain at the OS by the system calls only. So communication, as you see, there are two common models of enterprise communication: message passing model and the shared memory model. So as we're discussing, suppose this is a program of C program. This is a C program. I am somebody write, and once you're executing this program, what is executing means the microprocessor will execute. This is the only thing microprocessor will execute. These instructions. Each line is instruction only. Each line is instruction. So once it is coming for execution, this become a process. Process 0, process 1. Each line is a process only. When it comes for the execution, process 0, process 1, process 2, process 3, process 4. So once one process entered into the microprocessor for execution, this will intimate to the other processes which are in the queue for execution. That is called message passing. And message passing, it will leave the message for the processes once it's entering into the microprocessor execution. That is called that is nothing but message passing model. Communicating processes exchange messages with one another to transform information. So this is an interprocess communication. Process will intimate to another processes what is happening around the system. So these are maintained by the system calls on the hardware. Whatever the hardware is concerned, your OS will not maintain, but inside the kernel is a part, but system call is a part of OS only. So normal functions will not maintain these records. In the shared memory model, processes use shared memory, create and shared memory attach. System calls to create and gain access to regions of the memory owned by the other process. Messages can be exchanged between the processes either directly or indirectly through mailboxes. So this is types of system calls. You can see what are system calls available in the different operating systems. Regarding process control, in Windows we create process, exit process, wait for signal, object. So these are the system calls which are concerned for the process control. Whereas in the Linux or Unix, you got fork, exit, wait. These are the system calls for creating the process. We use fork, and exiting process, exit. For wait for signals, wait. These are the system calls concerned for the process control in the Unix. Linux is a flavor of Unix. So these are Unix system calls. And file manipulation. What are the system calls are involved in the kernel? Create file, that is open file in the Linux. Read file, same read. And write file, write. Close file, close handle, that is close file. So these are the concerned system calls which are available in the kernel, which are handling directly the operation, final operation. So these functions are not in the hand of user. These are in the control of the kernel only. So OS OS will call the kernel. OS will understand what user wants, and in turn it will invoke the consent file in the kernel. These files, once you add to the kernel, the user cannot touch. User cannot have any direct access to the system calls. So only OS will invoke the system calls which are available in the kernel. So what are the device manipulation? The device manipulation, what are the system calls in the Windows? So set console mode, that is I control, and read console, read, write console, write. So information regarding information maintenance, get current processes ID, get PID, that is in the Unix. So set timer, in the alarm is the system call in the Unix. So sleep and sleep. So communication consent, create pipe. Pipe is a line virtual communication between the one processor or that process. Create file mapping and shared memory. Shared memory open. So map view of file map mmap. So regarding protection, there are system calls in the Unix. Unix change mode, unmask, change owner. These are the system calls in the Unix. And the Windows set file security installation and initialize security descriptive set security descriptor group. So these are the different system calls available in Windows as well as Unix. So you look at this example. As I'm explaining previously also, this is a program written by you. So once after reading this program, this is user mode. Okay. So this is after compilation, we are writing in the hard disk. We are writing the hard disk. So writing the hard disk, for writing the hard disk, the OS will invoke this operating this write system call in the kernel. This is kernel mode. This write system call will write the entire program in the hard disk. It is writing the program in the hard disk. So it will save it in the hard disk. So what the user will do? User will write the program. After writing the program, he will enter save. So rest of the automatically when it is entering the save or when pressing the save, automatically user mode will be taken over by the OS. The kernel mode will come. The kernel mode, there are some pre-defined programs are there. That system calls are there. The one of the system call write. So for saving the data in the hard disk, it will invoke the write system call, and it will write the program in the hard disk. Very simple. These are system calls, how it works. So of this one, system programs. System programming can be defined as act of building system software using system programming languages. System programming, system will use that software. System software means we will understand how the compiler will work. Compiler is a part of system software. According to computer hierarchy, one which comes at last is hardware. Then it is operating system programs, and finally application programs. So what is if you look at this operating system, hardware is hardware. Your hardware. After this OS, this is OS. After this system programs, all these compilers, interpreters will be loaded here, and finally application program. So what application program you are writing, that will be available here. So that will interface system programming through the OS, through the hardware. That's what. So at the last, inside the kernel is the one who can interface with the hardware. So that is a part of your operating system. The system programs, your compiler, interpreter, and all. So application program you will write in the high-level language. So high-level language will interface with the system programs. Then operating system will understand it. Then operating system kernel will in the operating system. Kernel is the core part. Then operating system understand the system program, user program. Then finally it will work with consent system call. The consent system call will get the job done. So this what system programming. Program development and execution can be done concurrently in system programs. That is what we write simply. So for writing a Java program, suppose you want to write a Java program, you want to compile a Java program. So without JDK, we cannot write Java program, we cannot compile, we can execute, because there will be Java compiler, Java interpreter. That is a part of system programs. Application program, we writing Java. That's what. So it is traditionally lies between user interface and system calls. So user can only view view up to the system programs. He cannot see system calls, because system calls are not in the hand of user, because the system call wants you, because everything is done by human beings only. So we will design, we will OSD, that is OSD. OSD means operating system designing. So somebody has made OS. How it is made? They are made. They will create one package. They keep on adding the programs what user wants. So these programs are .exe files. So once you install this OS in the hard disk, then it will work as a OS, as a that what we have seen in the previous. So system programs, they can be divided into three categories: file management, status information, file modification, like this. So in the file management, these programs create, delete, copy, rename, print, dump, list, and generally manipulate files and dictionaries. So I will tell you one thing. So this program, suppose you are writing a program and save it, or copy it. Once you are copying, simply which program is helping you to copy this complete entire data and save somewhere else, or store somewhere else, and we are simply writing a print command. We are giving some program, right? We are giving print command. So who is helping you to do this one? So all these things will help in the coordination of the application programs, system programs, software, hardware. Finally, get the print. That's what. It's the status information. It simply asks the system for date, time, amount of available memory, or disk space, number of users, or the similar status information. Others are more complex, providing detailed performance, logging, and debugging information. So for everything, status information. Suppose what is today date and the similar status information. There are more this disk space. What is the memory available? All these things will be maintained by the system programs. So file modifications. So several text editors may be available to create and modify the content of files stored on disk or other stored devices. There may also be a special command to search contents of file or perform transformations of the text. So the computer cannot do anything its own. It is a passive unless you initiate some initiation, then the OS will do all the jobs. So that's what, for everything there will be a program running in the OS. That's what we have to understand. In the OS, what user wants, the consent program will be there. So simply is asking to do the job. In turn, the OS will invoke the concerned system calls or some system programs, and the OS is getting done job. So that's what everything will be done by OS only. OS means inside the OS there are some programs. These programs only we understand. So suppose programming language supports compilers. Suppose we are writing a C program. So for this, you are writing a C program for execution and compilation, simply can't do. So for doing this one, we have to install Turbo C. For C, you have to Turbo C, and for Java, we have to install JDK. For Python programs, you have to install Python. So, to execute this Python programs, you have to use Python compiler, the interpreter, and this for everything. This is a system programming for the C, Turbo C, and JDK interpreter and compiler, and this Python interpreter. So that's for these are the system programmings. These are the system programmings, and this is application programs. You will write. So this is the environment. So compilers, assemblers, debuggers, and interpreters for common program languages such as C, C++, Java, Perl, and the Perl are often provided with this operating system are available as a separate download. The program loading and execution. Once the program is assembled or compiled, it must be loaded into the memory to be executed. The system may provide absolute loaders, relocatable loaders, linkage, daters, and overlay loaders. These are softwares for executing simply a program. It's not possible directly by user. So it is a supporting software for executing our programs. So communication. These programs provide the mechanism for creating virtual connections among processes, users, and computer systems. They allow users to send messages to one another, screens to browse web pages, to send email messages, to log in remotely, or to transfer files from one machine to another. For everything, there is a systematic procedure, system calls, system programs, application programs are interfacing each other. So they can be divided into three categories. These categories: background services. All general purpose systems have methods for launching certain system program processes at boot time. Some of these processes terminate after completing their task, while others continue to run until the system is halted. Constantly running system programs processes are known as the services, subsystems, or daemons. So, as I explained, so by default, OS is loaded into the C drive. OS into drive into C drive in the hard disk. Once you switch on the system, so automatically OS will be transferred to your RAM. So this I told booting, booting, booting. After OS transfer to RAM, it will check all peripherals, your keyboards and your memory and everything. Will check. Once it's everything ready, then you will get the icons on the screen. Then it is called system is ready for the working. System is ready for the working. System is ready for the working. So So backgroundly, something is working back in the background. All general purpose systems have methods for launching certain system program processes at boot time. This is called boot time. Some of these processes terminate after completing their task. That's task in the sense checking the peripherals, checking the memory, checking everything, date and time. They will vanish. While other continues to run until the system is halted, till the system is closed or shut down. So some systems are running back end in the system. Constantly running system programs, processes are known as services, subsystems, and daemons. They're working behind in the system in the OS. So the view of the operating system seen by most users is defined by the application and system programs rather than by the actual system calls. This is what we understand from the this is system programs user. This is user interface and system programs of this application programs. System calls kernel like this. OS. This is OS. So production security. The production security requires that computer resources such as CPU, software, memory, etc. are protected. It extends to the operating system as well as the data in the system. This can be done by ensuring integrity, confidentiality, and availability in the other operating system. The system must be protected against unauthorized access, viruses, bombs, etc. So, For production and all, we provide some other programs in the ways they will they will be available in the system till the system is stopped. So these protection and security are programs like your firewalls and all. They'll work for system protection, and we'll put the stop we call password and all. So another other access will be stopped. So operating system is needed to design and implement, because without proper design and implementation, any system cannot work properly. Every aspect for any development, a proper design and implementation should be necessary so that it can work in a good manner and easily debug if any failures occurs. A design and implementation is necessary part of an operating system, and this technique can be used by every user who uses computer. So design goals, we will see operating system design and implementation. As I explained previously, operating system is not a language; it is a package. As you can say, package, and there is a systematic procedure. We write the Java program, C programs, and this is one program. After compilation, we will add it to the OS. This is OS. So like this, we will add different. This is one of the application program. This is one of the application program. So we will add to this one in the OS. Like this, we will write different application programs, and we will, after compilation, we will add to the OS. So like this is nothing but a designing of the OS. How to design? To designing goals, mechanism, implementation, we will see. Operating system design goals. So it is quite complicated to define all the goals and specifications of an operating system while designing it. The design changes depending upon the type of the operating system. That is, if the batch system, the time shared system, single user system, multi-user system, distributed system, there are different types of operating systems are there. As for that one, once you are designing the OS, what programs you have to write and what programs you have to add to the OS, that all things will be vary from situation to situation. So there are basically two types of goals while designing the operating system. These are user goals. What the user wants, that's the main thing. The operating system should be convenient, easy to use, reliable, safe, and fast according to the user. However, these specifications are not very useful, as there is no set of methods to achieve these goals. So, as of now, what type of operating system is required for the user? So, we will design as per the user's convenient. So, system goals. The operating system should be easy to design, implement, and maintain. These are the specifications required by those who create, maintain and operate the operating system, but there is not specific method to achieve these goals as well. So operating system and mechanisms and policies. There is no specific way to design operating system. It is highly a creative task. It is not a single man task. So there are several general software principles that are applicable to the operating systems. The subtle difference between mechanism and policy is that mechanism shows how to do something and policy shows what to do. Policies may change over time, and this would lead to change the mechanism. So it is better to have a general mechanism that would require few changes even when policy changes occurs. So operating system implementation. Once an operating system is designed, designing in the sense nothing but just I explained now. This is OS started first one source code. So package one. So I will add one program. This is a program. I compare it. I will add it. So this is one of the application program. Just like regarding printer or mouse. So I will write program and add to this one. So once it is completed, once this is completed, all respect, this is our OS. I will install in the system. So it will work. That is a designing part of the OS. So once an operating system is designed, it must be implemented, because operating systems are collections of many programs, as I explained, many programs written by many people over a long period of time. Implementation process, which is most important for the operating system that we have to implement in the sense we have to deploy the system. Deploy the system. It is difficult to make general statements about how they are implemented. Earlier, they were written in assembly language, but now high-level languages are used. So, the first system not written assembly language, but the master control program for Boros computers. So, advantage of high-level language and disadvantage of high-level language. So, code is written more fast, it is compact and also easy to debug and understand. The operating system can be easily moved from one hardware to another if it is written in a high-level language. So, disadvantage of high-level language. Using high-level language for implementing an operating system leads to a loss in speed and increase in storage requirements. So, in modern systems, only a small amount of code is needed for high performance, such as the CPU scheduler and memory manager. The bottleneck routines in the system can be replaced with the assembly language, and units of required. So we'll continue this operating system structure in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.